The universe has forever been a wellspring of miracle and secret, spellbinding the personalities of researchers and visionaries. However, every now and then, a discovery challenges everything we thought we knew and shakes the foundations of our understanding. Such a disclosure has of late risen up out of the profundities of room, because of the James Webb Space Telescope, JWST. 6 massive galaxies that appear to challenge established cosmological theories have been discovered using this revolutionary instrument. The involvement of renowned physicist Michio Kaku, who confirmed that these findings may herald a new era in our understanding of the universe, makes this discovery even more fascinating. Prepare yourself for a journey of discovery with profound repercussions that will test the very foundation of scientific thought. Michio Kaku recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists had previously thought did not exist due to his outstanding contributions to the field of physics. The scientific understanding of the universe could expand in new ways as a result of this research. It is essential to keep an eye on these developments because this discovery is both exciting and revolutionary, challenging existing theories of galaxy formation and evolution. The significance of these findings is emphasized by the endorsement of such a prominent scientist. The scientist Michio Kaku is a remarkable figure. He is regarded as an authority on both classical experimental physics and quantum mechanics and is a physicist of American and Japanese descent. Kaku, in contrast to some scientists who are more conservative and skeptical, was open to the surprising findings of the James Webb Space Telescope mission. His commitment to improving our understanding of the universe is demonstrated by his willingness to embrace new discoveries and share them with the public. We are delighted that this brilliant scientist has chosen to reveal the undisputed truth and break his silence. The energy and nearly entertained tone of the eminent physicist is obvious in his remarks on the revelation made by the James Webb Space Telescope, saying that it was a feature that provoked his curiosity. Go along with us as we investigate the ramifications of Michio Kaku and the group's revelation of these 6 gigantic cosmic systems. Kaku was a scientist who was open to new ideas at all times. All through his life, he exhibited a receptiveness to thoughts that rocked the boat, figuring out that Einstein's conditions of relativity and Newton's regulations, while key, were adequately not to catch every one of the intricacies of the universe. Kaku was aware that the findings from the new telescope had the potential to improve science. Even though many of his colleagues were unable to accept this viewpoint, it caused both supporters of the Big Bang and those who disagree with quantum mechanics anxiety and insomnia. However, Kaku only laughed at this. JWST uncovered the disclosure of 6 Goliath cosmic systems tracing all the way back to the early universe. Even though they did not form until 200 to 700 million years after the Big Bang, each of these galaxies had more stars than our Milky Way. The group of space experts who made the revelation are referring to these phenomenal systems as grandiose disruptors, on the grounds that, whenever affirmed, they would reform our whole comprehension of the universe. These findings have profound repercussions, suggesting that the universe's early years were significantly more dynamic and complex than previously thought. Something is off base here. According to the Big Bang theory, the universe experienced a catastrophe following the initial event. The first solid objects formed hundreds of thousands of years ago, but it took hundreds of millions of years for them to become dense enough to produce light. It is thought that complex structures like galaxies were formed much later. While our galaxy only occasionally produces new stars, the enormous luminosity of some of the newly discovered galaxies, which are larger than the Milky Way, suggests that they are capable of producing hundreds of new stars annually. When exactly the first galaxy formed is unknown. Specialists have not yet had the option to decide this. The only thing that can be said for sure is that dwarf galaxies probably started out as isolated stars or groups of stars that eventually merged to form ever larger accretion regions. Small galaxies grew together with other galaxies over time. This raises the question of whether the universe is much older than previously thought or whether complex arrangements of galaxies developed much earlier because, according to previous theories, massive and highly organized galaxies could not have existed at that time. Conservative science, which continues to have issues with this model, finds it difficult to accept this situation. This finding is not accepted by some branches of physics, and they question the possibility of age calculation errors. This is something that Kaku is aware of, and he says that there are numerous examples of outdated and incorrect theories that stubbornly persist because some scientists are well known. When a crucial experiment demonstrates that a number of these theories are incorrect, they are only discredited. Because of this, experimentalists, who ensure the honesty of theorists, are the key word in all sciences, but especially in physics. In fact, we on Earth know very little about how the universe started. In this, Kaku stresses the significance of constant testing and verification in the scientific method. Based on observations of the universe's expansion, the Big Bang theory was proposed in 1927. Based on these findings, it was determined that the universe began as a single point and has been expanding ever since. It was challenging for people and scientists at the time to imagine a universe with a beginning and end. It is beyond human comprehension to imagine a universe that has always existed and is infinite in both time and space. Scientists are still attempting to comprehend it today. Nevertheless, it is essential to re-evaluate these probabilities. The Big Bang theory has been the subject of decades of research, and these new pieces of evidence completely contradict it. However, science has demonstrated time and time again that re-evaluation and being open to new ideas are essential components of the scientific process, as is the validation of particular observations and theories. When Einstein was a child, it was thought that planets and stars occupied a specific space and were firmly anchored in the cosmos. In any case, we presently realize that all that in the universe is moving. Planets circle stars, stars travel through their cosmic systems at many kilometers each second, and whole worlds move quickly through the universe, their destinies not even unsurprising to us. This unique comprehension of the universe challenges long-held convictions and stresses the requirement for proceeded with examination and change of logical reasoning. Today, researchers are tested to acknowledge awkward bits of insight and comprehend that speculations are not outright bits of insight until they are thoroughly tried or affirmed by exact perception. The realization that galaxies are distancing themselves from one another and that this distance is proportional to their distance from Earth gave rise to the concept of the Big Bang. Hubble's law, or this observation, suggests that the universe is expanding. This advises us that science is continually advancing and that researchers should be available to new disclosures and re-examine existing speculations in view of accessible proof. Long-held cosmological theories have been re-evaluated as a result of these unexpected discoveries, which have challenged our current understanding. In their research into the universe, scientists use redshift as a tool to measure specific quantities. The term redshift, which is also referred to as the Doppler effect, refers to the color shift that occurs when the light source and the observer move in relation to one another. To comprehend this, picture yourself standing still and observing a car approaching. You can hear the engine noise getting louder as the car gets closer to you. However, the engine noise changes as the car moves closer or further away from you. Indeed, the car moves forward, which alters the engine noise. With lights, the same thing takes place. The light we see changes to bluer hues as a light source, like a distant star, gets closer to us. On the other hand, the light changes to redder hues as the light source moves away from us. Redshift is the name of this phenomenon. For space research, physicists convert redshift values into speeds and distances. However, it is essential to keep in mind that even insignificant deviations from these measurements can have significant effects. Current measurement methods are currently being revised. We are forced to question whether the most recent data on our universe are actually based on redshift errors or whether some scientists are simply denying the facts. The study's data and methods must be thoroughly scrutinized in order to answer this question. The assessment and reassessment of flow estimation procedures feature the advancing idea of logical exploration. The investigation of our universe, with its huge spaces and complex heavenly bodies, proceeds to intrigue and challenge researchers all over the planet. Each discovery reshapes our understanding of the universe and pushes the boundaries of human knowledge, from the earliest theories of the universe to the most recent discoveries made possible by cutting-edge technology. The question of where galaxies came from and how they changed over time is one of cosmology's most fundamental and enduring concerns. Galaxies are cities made up of gas, dust, dark matter, and stars that are held together by gravity. Not only is it important to know how galaxies form and change, but it is also important to know whether or not existing theories, like the Big Bang theory, are correct. Since its inception nearly a century ago, the Big Bang theory has proposed that the universe has been expanding from a single, infinitely dense point.